Since we've wiped out all the data from the original database, I'll show you another feature of migrations, seeding data into a database. Seed data is specified in the model builder with a method called hasData, and you apply that to a particular entity. So we'll seed some authors into the database, and I'm using the generic entity method of the model builder to tell it I want to do something to how the model builder sees the author entity. What you pass in to the hasData method is actually an instance of the class you're using to seed the database table. So here I'm creating a new author. And then you need to supply values for the non-nullable scalar properties. And most importantly, even if your database generates primary keys, you still have to supply values for the keys anyway. When you add a migration, EF Core will read this hasData method and create migration logic for the inserts. And then migrations will apply them either directly when you update the database or add the relevant SQL to any script you create. Let's go ahead and get some authors back into the database. Here's the onModel creating method, and I've set up hasData to add a new author with the ID 1, first name Rhoda, and last name Lerman. You can also pass in an array or some type of collection of objects. Here I'm pre-creating an array of 5 more authors, and notice I'm setting their IDs 2, 3, 4, 5, and 6, and then just using the array as the parameter of hasData. While this is the most common way to use the hasData method, you can learn a few other ways in the EF Core docs, and I'll put a link in the resources at the end of the module. Remember earlier when you learned about the workflow for model changes and how the snapshot file is involved in that? Well, now that you're aware of the seeding feature, I want to add a little more information to that. Migrations also reads the hasData information. So when I run this next migration, it's going to notice that there's seed instructions. It will compare it to the previous snapshot, which had no seed instructions. And therefore, since that's actually the only change that I've made to the model, it knows that the migration file it needs to create needs to include those database inserts. And it does store that into the next snapshot. So if I add some more hasData logic later, it will know which is new and which was already taken care of. Next, I've added a new migration called Seed Authors. And you can see that this uses the migration's insert data method to describe the insert. In this case, the SQL Server provider will ensure that it's okay to insert primary key values for the operation. And in the down method, since we know the IDs of each of the new rows, this code unwinds the migration by deleting each of the rows. Now I can call Update Database in the Package Manager console, and it tells me that it's applied the Seed Authors migration. Here's the migration history table, where you can see that it's tracking both migrations now, and here's the author table with all its new data. I do want to be sure you understand that this new mechanism isn't destined as a solution for every seeding scenario, and many teams may already have their mechanism for seeding test databases in place. It's best for situations where you want to seed with static data. In other words, you don't expect that seed data to change after it's been seeded. Well, at least not changed frequently and dramatically. You should avoid combining this method of seeding with other methods. Otherwise, you could get side effects like overwriting externally seeded data. Another scenario where this method is helpful is when the seed data doesn't have a dependency on anything else in the database. And again, this is to avoid the possibility of side effects. This method is great for testing where you need data in your tests and you want to be sure that they start with a consistent set of data. There's one last point I want to make sure you're aware of about seeding. If you use the hasData method for seeding in your DB context, the ensureCreated method will also recognize and execute that if that method is being used to create a new database. Now we have 2 migration files, so I want to be sure you know a little more about how migrations handles things when you do have more than one migration. You already saw that Update Database knew to only apply the latest migration. That's because part of the Update Database logic is to check the migration history table in the database. So it saw that initial had already been run. Scripting, however, doesn't work that way, and for important reasons. Imagine you have a number of developers on your team sharing this code base, but using their own development databases. There's a good chance that their databases are out of sync depending on what they're working on. And if they're using Update Database, that's not a problem. But scripts are different. Scripts won't check the database, so it has to be smarter. Let's look at the default behavior of script migration when we have more than one migration file. Script migration scripted out all of the logic from all of the migrations, even recreating the authors table and the books table. This would fail miserably on my machine because I already have those tables in my database. So if you're going to use scripting, keep in mind what scenarios this makes sense for. For example, testing, where you might be starting with a fresh database each time. The smartest option, in my opinion, is to use the idempotent parameter, which is -idempotent. This will generate SQL that checks to make sure something doesn't exist before it creates it. And it does this by checking which migrations are listed in the migration history table. The script wraps each command in an if not exists statement, checking for the particular migration in the history table. So if the initial migration is not in the history table, then it will go ahead and create the authors table. Same for the books, and then for inserting migrations into the history table. All of the logic for that first migration is wrapped in a transaction, so there's a commit at the end. Then it works on the next migration. A new transaction started. It checks to see if the seed authors migration is in the history table. Then it checks the identity columns of the rows. And now you can see for the SQL Server, it's setting identity insert on for the authors table, so it'll be allowed to push in those key values. And then after it executes the insert, it turns identity insert back off. Then it inserts the migration into the history table and commits that transaction. There's one other facet of scripting I want to be sure you're aware of. Looking at the help for script migration, notice that it has two arguments, from and to. Both of these arguments have defaults. From defaults to what they call the initial database, in other words, the very beginning. And it doesn't matter what you named that migration, I just happened to name it an initial. And when I first ran that, because I didn't provide any arguments on that first pass, that's exactly what happened, where it was going to create the authors table, even though I already had one. But if you want to control it, from can be a little confusing. It doesn't mean the first migration you want to run, in other words, the seed authors. What it means is what starting point are you working from? So you would specify the latest migration that was run. So that means my from should be my migration called initial. When I use initial as my argument, then the script only has whatever logic came after initial, in my case, the seed author logic. You've seen me use migrations to create a database from a DB context and classes. It's also possible to reverse engineer an existing database into a DB context and classes. Typically, this is a one-time procedure to get you a head start with your code if you're working with an existing database. At some point, EF Core will support updating the model with database changes, but that's not possible with EF Core 6. Also, with the current version, it's not easy to begin by reverse engineering an existing database and then migrate the database with model changes. So I'll provide a link in the resources to a blog post by Christos Matskis that explains how to make sure you can use migrations after creating your model from an existing database. I'm starting with a new solution that has a .NET class library project in it. And I've already added in the EF Core SQL Server package and the EF Core Tools package. The PowerShell command to use for this task is scaffold-dbcontext. And if you're using the EF CLI, it's .NET EF dbcontext scaffold. Here's a list of all its parameters, and you can see that there is some flexibility as to options like where the files should be created and what the DB context should be named. The provider and connection parameters are required, though, which makes sense. I'll run the scaffold dbcontext command with just the required parameters, and the connection is the connection string for my legacy database, which is in single quotes. That's because there's spaces in the string. The provider is Microsoft Entity Framework Core SQL Server. When I run this, watch the project in the Solution Explorer. a bunch of new files were added in. Since I used the database that we just created, the classes should be familiar. Scaffolding defaults to singularizing the names, so the class names are author and book, which is more natural for the class names. Here's the author class with its ID, first and last name properties, and it has an I collection of books. Recall that I used a list for the books. The book's I collection is also marked virtual. This is a setup for the possibility of enabling a feature called lazy loading. I'll be talking about this further on in the course when we start looking at dealing with related data. But these are EFCore's defaults, which are really just a stake in the ground, and you can make the classes your own once the scaffolding's done. Also, the scaffolding did kindly ensure that the book collection is instantiated up front, so we don't have to remember to do that in code constantly. The book class is also familiar, except that the convention for scaffolding creates a navigation property pointing back to the parent, and that's this author property. I didn't happen to have that in the book class that I created. EFCore has a lot of ways to sort out relationships, and this is just another path. Also, this author property is marked virtual, as you saw with the books collection in the other class. Again, you can modify all of that to suit your needs. Now let's look at the new dbContext class. It created DB sets for both of the classes that it created. And if the scaffolding had created more classes from more tables, there would be DB sets for every one of them in here. And that's another default, which you can change if you want. It also put the connection string directly in the onConfiguring method with a note that you might not want it there for security reasons. In fact, the same message was displayed in the package manager console when the scaffolding was done. I'll go ahead and delete that warning from the codebase. And remember, I had pointed out that I put the connection string there just for the benefit of making the demos simple. And notice the check to see if the options builder is configured or not, in case you've configured it outside of the DB context. And it's done something here in the onModelCreating method, and that's a method we haven't looked at yet. Recall that EFCore has defaults that it follows when it's reading your classes in the DB context in order to determine what the database schema looks like. These are referred to as conventions. Sometimes those conventions don't align with your real intent. So in the context file, we have the ability to tweak how Entity Framework Core will interpret the model, and you do that using what's referred to as the Fluent API. These additional configurations will override the conventions so that the classes can get mapped correctly to the database. There are a lot of conventions and a lot of ways to override them. Another path for overriding conventions is using data annotations. These get applied directly in your business classes, and the mappings you can achieve with these are much more limited than what you have access to with the Fluent API. I've always preferred to use the Fluent API over the data annotations, and that's what I'll be using in this course. Interestingly, these three mappings are not telling the context anything that's not following the conventions. Remember, the database that we're reverse engineering was created using EFCore's conventions. This is actually a bug in the scaffolding that the EFCore team is tracking to fix in a future update. Having them here won't hurt anything. It's just some info that EFCore already knows about your data model. So the scaffolding has added some Fluent API configurations into the DB context. You'll learn more about working with the Fluent API further on in the course. That's a quick look at reverse engineering, which generated domain classes and a DB context as a stake in the ground, taking advantage of the existing database. This really gives you a head start on the code you need to write. But it will be up to you to refactor those classes to incorporate your business logic and make things work the way your software requires. Keep in mind that the built-in scaffolding is not the only path to reverse engineer a database. Another excellent option is the reverse engineering feature of the EFCore Power Tools, a free Visual Studio extension built by my friend and Microsoft MVP, Erik Alskov Jensen. He's known in the community as Erik EJ. Erik has built a number of very rich and useful extensions for Visual Studio in his free time.